In the past, factories were filled with human workers. Today, a new kind of worker is changing the face of industry, the industrial robot. These are not the robots of science fiction capable of independent thought. Instead, industrial robots are sophisticated machines designed to perform specific tasks. They are revolutionizing how we manufacture goods, from cars to smartphones. The first industrial robot, called Unimate, was used in a General Motors factory in 1961. Unimate was a simple hydraulic arm, but it marked the beginning of a new era. Over the decades, robots have become faster, more precise, and capable of performing an increasingly complex range of tasks. The development of computers and software has been crucial in advancing robotics. Today's industrial robots are controlled by sophisticated software that allows them to be programmed for a variety of tasks. This flexibility makes them invaluable assets in many industries. As we delve deeper into the world of industrial robots, we'll explore the key components that enable them to function and the impact they have on various industries and the global workforce. Imagine a worker in a factory. To do their job, they need to see the parts they are working with. They need to feel if something is too hot or too cold. Industrial robots need this ability too. This is where sensors come in. Sensors are like the senses of a robot. They provide information about the robot's surroundings. Just like our eyes allow us to see, robots use cameras as visual sensors. These cameras capture images of objects, allowing the robot to see its environment. But robots don't just need to see. They need to touch and feel too. Pressure sensors tell the robot how much force it is applying. This is important for tasks like gripping delicate objects without causing damage. Temperature sensors warn the robot if something is too hot or too cold. This is vital for safety, especially when working with hazardous materials. By processing information from various sensors, robots gain an understanding of their environment, allowing them to perform their tasks safely and efficiently. Industrial robots are known for their precise movements, mimicking the actions of a human worker but with greater accuracy. This movement, the ability to pick up objects, rotate and move with accuracy, is made possible by actuators. Actuators are like the muscles of a robot. They convert commands from the robot's control system into physical motion. The most common type of actuator used in industrial robots is the electric motor. Motors provide rotational force, which can be used to turn a shaft or spin a wheel. By connecting motors to different mechanical linkages, robots can achieve a wide range of movements. For tasks requiring greater strength, hydraulic actuators are often used. These actuators use fluid pressure to generate force. Hydraulic systems are very powerful and are suitable for lifting heavy objects. Pneumatic actuators, on the other hand, use compressed air to generate force. These actuators are typically used for smaller robots and for applications where speed is important. The choice of actuator depends on the specific application and the required speed, force, and precision. We've seen how robots sense their surroundings and move using actuators. But what tells the robot what to do? This is where the control system and software come in. The control system acts as the robot's brain, while the software is like its thoughts or instructions. Think of a chef following a recipe. The recipe tells the chef what ingredients to use and what steps to follow. In the same way, the software provides instructions to the robot's control system, telling it what actions to perform. The control system takes these instructions and coordinates the actions of the robot's actuators based on the information received from the sensors. This might involve moving the robot's arm to a specific location, picking up an object, or performing a complex assembly task. Programming industrial robots was once a complex task, but modern software has made it much simpler. Today, even those without extensive programming knowledge can learn to program robots using intuitive interfaces and visual programming tools. Few industries have been as profoundly impacted by industrial robots as the automotive industry. From welding and painting to assembly and inspection, robots have become an integral part of modern car manufacturing. In the past, assembling a car was a labor-intensive process. Human workers would perform repetitive tasks in often hazardous environments. Robots have changed all of that. One of the most common uses of robots in automotive manufacturing is in welding. Welding robots can perform spot welds with incredible precision, ensuring the structural integrity of the vehicle. They can work tirelessly for long hours, increasing productivity significantly. Painting is another task that is well suited for robots. Robots can apply paint evenly and consistently, eliminating the inconsistencies that can occur with manual painting. This results in a higher quality finish and reduces waste. The use of robots in automotive manufacturing has led to several benefits, including increased efficiency, improved quality, and a safer working environment for human workers. As automation continues to advance, we can expect even more innovative applications of robotics in the automotive industry. While robots in the automotive industry are often large and powerful, the world of electronics manufacturing demands precision on a much smaller scale. From smartphones and laptops to gaming consoles and medical devices, electronics are getting smaller and more complex. Assembling these intricate devices requires a level of accuracy and dexterity that is beyond human capabilities. This is where small industrial robots, often called collaborative robots or cobots, come in. These robots are designed to work alongside human operators, assisting with tasks that require extreme precision. For instance, a cobot with a specialized gripper can place tiny components onto a circuit board with incredible accuracy, ensuring that each component is perfectly aligned and soldered in place. Their ability to handle delicate components with care reduces the risk of damage, leading to higher product quality and reduced waste. The use of robots in electronics manufacturing has played a pivotal role in making electronic devices more affordable and accessible to consumers worldwide. As technology continues to shrink, we can expect even greater reliance on robots to manufacture the next generation of electronics. While the automotive and electronics industries were early adopters of industrial robots, their use is no longer limited to the factory floor. Robots are branching out into diverse industries, revolutionizing sectors such as healthcare, agriculture, and even logistics. In hospitals, surgical robots are assisting surgeons in performing minimally invasive procedures with greater precision and control. These robots allow for smaller incisions, which can lead to faster recovery times and reduced risk of complications. In agriculture, robots are being used for tasks such as planting, harvesting, and even weed control. These agribots can work tirelessly in all weather conditions, increasing efficiency and reducing the need for manual labor in an industry facing increasing labor shortages. Even in the service industry, robots are making their mark. From robots that can serve food in restaurants to robots that can clean floors in hotels, the service industry is slowly embracing automation to improve efficiency and address labor challenges. The rise of industrial robots has brought about a paradigm shift in the way we manufacture goods and deliver services. The benefits are undeniable: increased efficiency, improved quality, reduced waste, and a safer working environment for humans. Robots can perform tasks that are too dangerous, repetitive, or simply impossible for humans to do. However, the increasing automation of industries also presents significant challenges. One of the most pressing concerns is the potential for job displacement. As robots become more sophisticated and capable, they threaten to replace human workers in a wide range of jobs, from factory work to truck driving. Another challenge is the high initial investment cost associated with implementing robotic systems. While robots can lead to long-term cost savings, the upfront investment can be a barrier for some businesses, particularly small and medium-sized enterprises. Addressing these challenges will require proactive measures from policymakers and industry leaders. This includes investing in education and training programs to prepare the workforce for the jobs of the future, and exploring policies such as universal basic income to mitigate the impact of job displacement. The field of industrial robotics is constantly evolving. As technology continues to advance, we can expect even more sophisticated and capable robots to emerge, further blurring the lines between human capability and artificial intelligence. One of the most significant trends in robotics is the development of robots with advanced artificial intelligence. These robots are not simply programmed to perform a specific task. They can learn from their experiences and adapt to changing environments. This opens up possibilities for robots to take on even more complex and unstructured tasks, such as those requiring problem-solving and decision-making. Another trend is the development of cloud-connected robots. By connecting robots to the cloud, manufacturers can access vast amounts of data and computing power, enabling robots to learn from each other and improve their performance over time. The future of industrial robotics is ripe with both promise and uncertainty. While robots have the potential to create new jobs and boost productivity, their impact on the workforce and society as a whole remains a subject of ongoing debate. One thing is for sure, the future is automated, and it's up to us to shape how we want to live and work alongside our robotic counterparts.